So in this video, I'm just going to discuss a brief overview of 3D machining. Now, this isn't to say that I'm going to tell you how we machine the parts in 3D. There's hundreds of different ways you can machine a single part, but hopefully this video should give you an understanding of how we hold the part, why we need extra material, and just to give you a better understanding of what we require from you for those files and for the stock. So here I've just drawn a very simple semi-sphere, just as an example. It's not something we've cut recently, but as you can see, we're going to position this on the bed. Now, if we were cutting this from solid material, we've got to hold this piece down to our bed. Now, to do that, we often use mechanical fixings such as brackets and screws. If it was cut from, like, let's say foam, then you could just use double-sided tape and it wouldn't be such a problem. But for like a solid timber, the force that gets pushed through it when we're cutting is quite high. So we generally like to have a nice mechanical fixing in there to ensure that the part doesn't move around. So in here we'll have our piece of stock, and this will get bracketed down onto our MDF bed. Now, because of this, we need excess material. So although the part here is only 150 mil wide, our stock that we're actually putting within it is about 210. So we're quite a bit wider. Now that's because we need a lot of room for the tools to go down around this and to make sure they don't hit our screws as well. So as a general kind of rule of thumb, what you can expect is to have about 25 mil, 30 mil basically from edge of part to your edge of your stock. If you put 30 mil all around your part, then we're not going to have a problem. So first of all, I'll just run through the simulation of how we cut this. Is that we just rough it out and then we'd run through and do a kind of finishing operation after we've removed the bulk of the material, which would just come down in a spiral to finish this off. Now we keep that away from the bottom, and then our final pass is done with a cutter, and we'll leave tabs to hold against this frame. And again, that's just to stop the part moving around. These will have to be cleaned off after. Often we can do that in-house. Occasionally, as I'll show you in a sec with another part, they're going to be a lot thicker and bigger tabs, and it gets a bit more complicated. So that's a simple understanding of how we position your part within a stock and why we need that extra space. So here we put a bracket on this corner. We probably put one on every corner just to ensure we've got a good fixing. Now, that's kind of like a simple 3D shape, which is only single-sided. Often we will get a more complex shape, and that will need to be machined from both sides. So here are some pieces that we machined recently. Now, as you can see, these parts have to get machined from both sides. And the way we do that is we basically hold it within this frame like an Airfix model. So these red sections, the blue section represents our part, and the red sections here represent our tabs that hold it to our frame. Now, in order to machine this, again, we're having to create excess stock around in order for us to add our screws and our brackets. And we're also having to, machine quite a bit away from this part as well. So although your part is only, 120 mil wide, we're going to need another 50 mil, at least around that. So don't expect, if you've got a 3D part, for us to be able to machine it from very tight stock. The more stock we have to play around with, the better it's going to be for us. Now, I'm not going to run through the programming of this because it's quite complex and there's a lot to it, and it's not really something that's going to help you. I just wanted to show you the rough layout of how we'll machine these parts. So once we've machined this one side, these parts then just get flipped over like that, and we'll then machine the other side. So this is all done on 3-axis CNC routers, so you can get very complex parts just on our 3-axis machines. We don't actually need to use the 5-axis for a lot of this kind of work. But in some other videos, which I'll release shortly, I will be discussing kind of setting up for 5-axis machining and the advantages and disadvantages of it. So any kind of complex parts like this, do send over to us and we can discuss through with you. Sometimes slight tweaks and alterations need to be made to help with machining, but those are stuff we can discuss on project basis. I hope this has been helpful, and yeah, get in touch with your next project.